It turns out from the observations that this filament of material is material of the galaxy, gas and dust and stars and so forth, that's been drawn out in the ejection. But the astonishing thing, the controversial matter, is that this galaxy is a much higher redshift than this.
Now, NGC 7603 has one redshift of about 8,000 kilometers a second, and the other galaxy has a much larger redshift. So how can they be connected? Well, these data were published years ago, and everybody said, well, this is just a chance location of a background galaxy near an interesting foreground galaxy. And that spiral arm has nothing to do with it. It's just the whole thing is just a chance.
If you see two objects close together with very different redshifts, you only have one of two explanations. One is, as I say, that a large part of the redshift has nothing to do with distance, and the other is that it's an accident. So the real issue that you come down to is how frequently do you expect to see accidents?
If you look carefully at the pictures that were taken of this field, you will notice two faint stellar objects that are in that spiral arm. One is close to NGC 7603, and the other one is close to the faint companion galaxy.
In the year 2001, when the two young Spanish astronomers worked on this with the Las Palmas telescope, they saw that there were these two condensations, stellar condensations. They looked like quasars, but everybody would have said that they had to have the same redshift as the central galaxy because they were obviously in this filament that had been ejected. What they found was that each of these objects had a much higher redshift, and that the filament itself had the same redshift and spectral composition as the galaxy from which it was ejected.
And they got some spectra using what's called the Nordic Optical Telescope in the Canary Islands on La Palma. It's not a very large telescope, but they got some excellent data, and they got spectra of these two faint objects, one by 7603 and one by the companion galaxy, and believe it or not, they showed that both of them were quasars. Not very high redshift quasars, but definite quasars.
Two of these quasars. Now this one will turn out to be quite good, but it's a very
It's a fairly big blow-up. This is only a couple of 1 second across. But it looks like it's extended.
Anyway, it looks right.
So we'll go ahead and move it and then narrow it up.
It's a chance to have many quasars around a galaxy as a background objects. Of course, you have some chance, but these are very, very low, and this is what should be answered. This is what should be answered. NGC 7603 is a very special case of this correlation. You find not only three objects with different redshifts in the neighborhood of a major safer galaxy. You also find the filament connecting all of them. So this is more important because the probability to have all these objects, not only in the neighborhood, but exactly in the filament is extremely low.
The galaxy, which is an active galaxy, two low redshift quasars, and another galaxy with twice the redshifts. In other words, you had four objects all connected together, apparently, by a luminosity, by a luminous bridge, each with a different redshift. Now that, I would say, is pretty conclusive evidence for the existence of non-cosmological redshifts.
We were lucky because we have found that the object has more controversy than expected. If in the past Chip Art thought, and Barbish and all other people that have dedicated some effort to research, this object. If they thought that there were two objects connected by a filament with different redshift, now we have discovered that there are four objects all connected by the same filament, and all of them with very different redshifts. So the Doppler redshift is discovered.
I think they have to look at it, and I think it's one of the most striking results that we have available. How they can make sense of it other than saying that these objects, that these redshifts of connected objects that are the same, more or less the same distance from us, that these redshifts have non-cosmological components to them.
The topic of the anomalous redshift is very important for most of the areas related with cosmology and extragalactic astronomy nowadays. If we assume, as it is done nowadays, that all the redshift are pointing the distance of the galaxy or the quasar or whatever, of course the results will be very different than assuming the other thing, that the redshift are due to other reasons. The distance of the quasars and the galaxies will be different, the energies involved in the process will be very different, so a lot of astrophysical processes will have to change.
Conclusive evidence that the expanding universe was not correct, and that the redshift distance law was not correct, and that we had to have some way of creating new galaxies with high redshifts.
It is normally argued that the Big Bang, for instance, the Big Bang cosmology, is against the anomalous redshift question. And of course, the Big Bang theory is the most important theory that we have nowadays to explain all that we know about cosmology, which is not too much, in my opinion.
There's a large body of work going on, observational work, theoretical work, which is based on the assumption that quasars are at their cosmological distances. If it turns out seriously that we're right, then all that work is in vain. We don't know anything like as much as we think we do by saying that the quasars are far away. And that's another huge problem for people to face up to.
One of the frightening things, I think, for conventional astronomers is to accept the fact, or to realize that these intrinsic redshifts for the quasars and peculiar galaxies and so on, active galaxies, means that a lot of the things which we thought were out at great distance in the universe are very much closer in. And in fact, you would have to say that what we call the local supercluster is much more crowded and contains many more objects than we previously thought. And then the question comes up, well, what is out beyond the local supercluster, and can we with any certainty identify any objects that are out there?
Be aware of what of our interpretations, because we cannot distinguish which objects have cosmological redshift and which objects have non-cosmological redshift. Then we cannot trust the redshift indicator as a distance indicator.
People who work on the origin of the universe, they ought to look at data of this sort, because they've got to understand this. And I've heard good friend astronomers say, well, there's more out there in the universe than we understand.
What's really happening in these systems is that the centers of the galaxies are the places where creation is taking place rather than just in a big bang. And so you're looking at all these mini bangs where matter and energy are actually literally being created. And this is an old idea which is not ours. Originally, it was due to the very famous Armenian astronomer Victor Ambartsumian, who only died a few years ago, who also argued that galaxies which appear to be coming apart and objects that are coming out of them are coming out of them. Very simple idea, but Ambartsumian, who was a very well-known theorist, always said you must look at the observations, and maybe if things are coming apart, appear to be coming apart, maybe they are coming apart. Conventional astronomers don't allow things to come apart. They always say there's enough dark matter in the system to hold it together.
I've come to the conclusion that what it is that will unseat an established prejudice, a strongly established prejudice, is one observation. One single observation, usually a very simple one.
The conclusion was very, very strong just from looking at this picture, that these objects had been ejected from the central galaxy and that they were initially at high redshift, and the redshift decayed as time went on. And therefore we were looking at a physics that was operating in the universe in which matter was born with low mass and with very high redshift, and as it matured and evolved into our present form, that we were seeing the birth and evolution of galaxies in the universe.